Problem solving examples. The initial population of rabbits on the farm was 50. That is our U sub 1. That is 50. And our R is equal to, it increased by 7%. That means 1.07. Okay. How many rabbits were present after 15 weeks? So if we need U sub 1, that is 50, we can say that is 0 week. U sub 2 is equal to 50 multiplied by 1.07, that is after 1 week. Okay, U sub 3 is equal to 50 multiplied by 1.07 raised to 2. As you can see here now, I hope you can see it now. We have, actually this is 1.07 raised to 0. So if this is our n, 0, 1, 2, we can say that this is 50 multiplied by 1.07 raised to n. But here we have u raised to n plus 1. It's strange to think that way because we used to have u sub n is equal to minus 1 instead here. You used to have this one. U sub n is equal to u sub 1 multiplied by r raised to n minus 1 instead. But now we have only n here. That means this one will be n plus 1. So to answer the first question there now, how many rabbits were present after 15 weeks? That means our n is 15. So you have u16. U sub 16 is equal to 50 multiplied by 1.07 raised to 15. Then if we solve that, 50 multiplied by 1.07 raised to 15, then we have approximately, not equal to, but approximately 138 rabbits. How about if we have 30 weeks? So we have U sub 31, that is equal to 50 multiplied by 1.07 raised to 30. So if we solve that also, that's 30 is equal to approximately 381 or 80. We take 81 because it's 0.6 rabbits approximately. How long would it take for the population to reach 500? So we have now this is now our u sub n plus 1. So we have now 50 multiplied by 1.07 raised to n is equal to 500. So if we divide both sides of the equation by 50, then we have 1.07 raised to n is equal to 10. Take the logarithm of both sides, then we have n logarithm of 1.07 is equal to logarithm of 10. And we have, if the base is 10, then we have, this will become 1, but don't change it. Logarithm of 1.07, we divide both sides. Then we have n now is equal to logarithm of 10, that's 1. So we have 1 divided by logarithm of 1.07. That is 34 years. 34 weeks. Another example, $5,000 is invested for 4 years at 7% per annum compounded annually. What will it amount to at the end of this period? Give your answer to the nearest cent. So we have our N is equal to 4, and then we have R is equal to 1.07 again. And we have now our U sub N plus 1, that is 5, because at the end, after 4 years, then we have U sub 1 multiplied by R, 1.07 raised to 4. And our U sub 1 is 5,000 multiplied by 1.07 raised to 4. And if we multiply that or solve that by the calculator, 5,000 multiplied by 1.07 raised to 4. Then we have approximately $6,554. Sorry, I forgot to read that. Give your answer to the nearest cent. So we will put our answer to the nearest cent. That should be equal to, what I got here is 6,553.98 Okay, more examples. How much should I invest now if I need a maturing value of 10,000 euro in 4 years time, and I am able to invest at 8% per annum compounded twice annually? Give your answer to the nearest cent again. Okay, so my U sub N plus 1 is equal to 10,000 euro. No? Is that euro? Yeah, that's euro. That's euro. Okay, and then my R now is, we have twice annually, so we have now 1 plus 0.8 divided by 2. Then we have 1.04. And my N now is, we have 4 times 2 because it compounded twice annually. That's 8. Now we have U sub N plus 1 is equal to U sub 1 multiplied by R raised to N. Then we have U sub 1, we don't know. U sub 1 multiplied by R, that is 1.04 raised to 8 is equal to 10,000. So if we divide both sides of the equation by 1.04 raised to 8, 1.04 raised to 8, this is now 1. So my U sub 1 is 10,000 divided by 1.04 raised to 8. Then I need to have 7,306.90 cents euro. So that's it about geometric sequences, and thank you for watching once again, and I hope you like what I am doing, and if you do, then please subscribe or just push the button like, and see you next time. On my next video I will be discussing series. Yeah, it's very related to sequences. but series will be. See you next time, and bye bye.